Good day once again. My name is Graphics. Today we'll be looking at another example on friction. It says a body of mass 50.99 kilogram lies on a rough inclined plane, and the angle of friction, the angle of 25, and it makes an angle of 25 degrees to the horizontal. It's supported by an effort P parallel to the plane. Determine the maximum and minimum value for which equilibrium can exist if the coefficient of friction is this. Now, I would like to take you down the memory lane. Solution. Now, the solution we have here is that we have the mass given, M, given to be 50.99 kilogram, and the angle at which it makes the inclined plane makes to the horizontal is alpha equals to what? 25 degrees. They say you should look for the force P, for which it said it is supported by an effort P parallel to the plane. Determine the maximum and minimum value for which equilibrium can exist. If so, we look for P maximum, right? And we're also going to look for what? P minimum. Two of them. And we know our coefficient of friction is given as 0.364. So let's move and see. I have my inclined plane coming in this direction. The angle that is formed with the horizontal, this is the horizontal here, is given as alpha, and that is 25 degrees, and the object is here. So this is the object at this point. Now, the maximum force is the force that tends to move the object up the inclined plane. That is the effort here. I will call it P. Start taking. And when P is acting forward, frictional force will say, where are you going? Because friction is the force that tends to opposite motion. And we have what? Our F, frictional force. So let me call it Fx or Ff. Frictional force, Ff. Are we good? Now also, there is a parallel force that tends to bring the object down. Probably the force of gravity that tends to want to slide this object naturally downward. So I'll call it Fx. Right? Now, if you apply the condition for equilibrium, so we say that summation of f of x is equals to what? 0. So we want to consider, so the force parallel to the inclined plane, summation of all the force parallel to what? To the inclined plane will be, so we're having summation of f of x, which is equals to what? B, which is equals to, both of them are moving downward, so it will be minus the frictional force Ff minus the force that tends to bring the object down. We'll call it the force of gravity bringing it down. Now, from here, we will say that this is equals to what? 0. We are moving forward. Recall, Ff, frictional force, is equals to what? Mu Fn. That is the coefficient of friction times the normal force. Now, we continue moving. So if I'm to write that, I will say the summation, that will say my P will now give me, all this guy will come to this point here. So I'll be having frictional force plus Fx, because when these two negative signs move across, the equal sign will become positive. So I'll have my P will be equals to, what is the Ff? Ff is mu Fn plus the Fx is what? W sine what? Sine alpha. So that is our Fx here. So any force that is coming down this inclined plane here is called W sine alpha. So from here we'll move forward. So recall, we know Fx is equal to W sine alpha, then Fn will be equal to what? W cos alpha. From this point, we'll substitute in our equation here, and we are going to be having the force P will now be equals to the mu. Fn is what? W cos alpha plus W sine alpha. So if we put our formula here, we are going to be having the force P will now be mu is given as 0.36364. Then the weight will be given as what? Mass times gravity. They will have our cos 25 degree plus mass times gravity sine 25 degree into brackets. W is equals to what? Mass times gravity. That is our weight. So from here we know the mass is 50.99. Recall, our mass is equals to what? 50.99, and gravity is equals to 9.81 meter per second square. This is in kilogram. So my force P will now give me 0.364 multiplied by 50.99, right? Then since it's in kilogram, we're going to, let us proceed. Now the gram will be 50.99 cos 25 plus 50.99 times 9.81, right, times, that will be sine 25. Now in this aspect here we have the gravity also here, so multiply it. We will now have that the P will now be this multiplied by 9.81. I didn't include that earlier, so then times 9.81 here because of the G. So from here we'll be having, we're going to be having 0.36 times 50.99, 0.364 times 50.99 times 9.81, 0.64 times 50.99 times 9.81. That is giving me this 182.07. So 182.07 cos 25. So we're having 165.01. 165.01 plus the next one 50.99 times 9.81. That will give us 500, right? So 500.21 times sine 25, and that will give me 211.39. So we have 211.39. So the maximum force P required will be plus 165.01. That'll give us 376.407 or 408 Newton, kilonewton per watt. Kilonewton, yeah, kilonewton. Are we good? This is in kilogram, we're leaving it in kilonewton here. This is our value here for our maximum value of P. Now we will now look at the minimum value of P. So for the minimum value of P, come down here, it will be, if I'm having this way, so this is the horizontal floor here, and the angle alpha equals to 25, and we have an object up. So the minimum value of P with the force that is trying to bring the object down. So since the force is acting downward, friction will tell it you go nowhere. That is frictional force up here. So frictional force is always opposing motion, and our normal gravity force F of x will always there. It's always constant at that position. So we have this. Now we'll move forward from here. Now for the minimum force is the force that is going down the inclined plane, right? So we say that the summation f of x is equals to what? 0, right? So we are going to write that the summation of f of x is the same thing as saying the force P, which is equals to, now if you look at this force now, this force here is acting downward, so it will be what? Negative f of x, that is fx. Now this one is going on, the frictional force that tends to oppose the motion will become what? Positive ff, the frictional force, which can be your fk or your fs. Now from here, my P, I'm taking the P equals to what? Is equals to 0, right? So equals to minus fx plus the frictional force ff equals to what? 0. So when this come here, the P will now be equals to, this is coming here become fx, this is coming to become minus what? Ff, right? That's our frictional force. But fx is equals to w sine alpha, and ff is equals to what? Mu fn, right? Which is equals to my P now will now give me w sine alpha minus mu fn, right? So from here also, but fn normal force is equals to what? W cos alpha. So input it here, our force P will now give us w sine alpha minus mu w cos alpha. So I'm replacing my w cos alpha, I'm replacing my fn with w cos alpha. So from here we move forward, the P will now be equals to, what is common here? W is common, so I'll bring my w out. I'll be left with sine alpha minus mu cos alpha, right? So what is the weight here? the weight is not given, so I will say P is equals to weight is equals to what? Mass times what? Gravity. Since it is not given in full, we will have sine our alpha minus mu cos alpha. So from here, P will now be given, the mass is 50.99, gravity is giving us 9.81 into bracket sine 25 minus mu is giving 0.364 cos 25. So from here, the force P will be giving us 50.99 times 9.81. That will give us 500.21 into bracket sine 25 will give us 0.4226 minus 0.364 cos 45 will give you 25 will give us 0.33. So P here will now give us 500.21 into bracket. If you subtract these two, we'll be having 0.093. So the force P will be equals to multiply these two, you'll be having 46.35 Newton. So that's the minimum force required to make the minimum force required for which the equilibrium can exist. So we'll meet in our next video. Thanks for watching. Don't forget to click on the subscribe button.